All right, welcome back, the genius. So in this chapter, we'll talk about bits and data type. Remember in our last session, we talked about how the levels of transformation, whereby you have a problem, you want the computer to solve for you. Then you write an algorithm. First of all, you put it in natural language. From there, you make an algorithm for it, create your program, your program, your ISA, your microarchitecture, your circuit, logic circuits, and then the device. So now we also mentioned that the devices, we have electrons. It's actually electrons that actually do this whole job for us. Any job you want the computer to do for you, it's actually the movement of electrons in the system, in the computer. And then we need some devices to control the movement of this electron. That's how we got to transistors. Okay. Now with these transistors that control the movement of these electrons. Now, I want you to understand before we actually go down to bits and data type, I just want to explain certain things for you here. Now, the thing is that the computer reacts to, you remember the transistor is a conductor, all right? It's like a wire that has, it either has electric current or it doesn't have. So when it has electric current, it is on. When it doesn't have electric current, it is off. And in that way, if it is on, it is 1. If it's not on, it is 0. So now, basically, the computer or the transistor reacts to the presence or not or absence of voltage on those transistors. We are not looking at, okay, is it 1.2 volts? Is it 15 volts? Is it 120 volts? No, that's not what we are looking at. We are looking at, is there volts, like is there presence of voltage, or there is not? So when there's presence, it is 1. When there is no presence, it is 0. Okay, don't worry, you're going to understand more of this when we get as we go along. So now the presence of voltage is actually 1. The absence of voltage is 0. And basically, it is the computer doesn't look at it that way, like um the presence or absence. Now look at it. Let's say a computer, let's say you're expecting, I don't know how to put this so that I don't get it confused, but I want to pass a message. Basically, the computer is looking at the voltage. Is it closer to 0 or is it very far from 0? So when, let's say you're expecting 1.2 volts, all right? Then if the voltage is something like 1.0, that means it is closer to that 1.2 that you're expecting. So that means it will be 1. But if it is 0.1 or 0.5, that means it is closer to 0. It would be 0. But the thing is that because of abstraction that we discussed earlier on, you don't need to understand all these things that I'm saying. But I just want to say them. If you understand them, fine. If you don't understand them, no problem. But definitely you're going to see these things as we go on. Okay? So now when there is a voltage or when there is no voltage, we have a bit. It's either 0 or 1. So what is a bit? Okay? What is a bit? A bit is the short form for binary digit. It is the smallest unit of data in computing. And remember when we were talking about the electrons, when we were talking about the transistors being on and off, we said that when it is on, it is 1. When it is off, it is 0. Okay? Then that is what we use to store data. So we are actually storing the state of transistors. So if you want to store data, all right, we are storing the states of transistors. If that transistor has current, if it is on, that means it is 1. If it is off, it is 0. Okay, so now we use bit to store data in computing. Now, we store data in your memory, the memory of the computer, you know that. Now, this memory is also made up of transistors, logic gates, logic circuits. So when we store a unit of data, which is the bit, all right, we are actually storing the state of the transistor that are used to make that memory. Okay. Now, back to what we are talking about. A bit is the smallest unit of data. So if you want to store data, you store data using bits. So if you want to store just 1 bit, we can a bit is enough to just store 1 bit. So a bit is the smallest unit of data in computing. It can hold only one of 2 possible values. Now you can see a bit can only hold only 1 or 2 possible values. It's either holding 0 or it's holding 1. Do you understand? So, but the question will not be, Since we can only store either 0 or 1, we can only represent just one unit. How do we now store more data? We are going to come to that. Okay, so when it is 0, it is off, or it has low voltage. Okay, when it is storing, when it is holding 1, it means that this transistor is either on, okay, high voltage, or true. Okay, so all digital information in computers, whether it's numbers, your text, your images, your videos, your sound, all right, they are all in bits. They are stored in bits, in zeros and ones. Now, we can have sequence of zeros and ones if you want to store more value. Do you understand? But if you just want to store 0 or 1 bit is enough. But if you now want to store more than 0 or 1, all right, that means you will need more a sequence of bits. The sequence of bits is that we have multiple, we have more than 1 bit used to represent data. So your text, your numbers, your images, your videos, the sound, all right? When you're playing music with your laptop or with your phone, these things are stored in zeros and ones, okay? All right. So if you take a look at the binary system, we'll still talk about binary system in details, but remember binary system, all right? The base 2. You remember in mathematics in secondary school, you remember the base 2 binary system, okay? Normally, we use base 10 from 0 to 9, but computers use binary system, all right? 0 and 1. There are only 2 numbers in the binary system, 0 and 1, but in the base 10, there are 10 possible numbers. In octa, there are 8 possible numbers. In hexadecimal, there are 16 possible numbers. So basically, we as human beings, we use the decimal system, but computers use binary system. So it's either 0 or 1. So each place value in binary is a power of 2. So now let's say we have a binary number like this. If we have a binary number like this and you want to convert it to decimal, all right, you actually you use the positional notation. Don't worry, we'll still talk about converting binary to decimal and stuff like that. We'll talk more about binary system later on. Okay, so if you convert this thing, now you can see the first from right to left, all right, the position of the first one is 0, the position of the second one is 1, the position of the next the 0 that follows this one is 2, and the position of the last one is 3. So you can do 2 raised to power of these positions. All right, then when you do 1, don't worry, I'm not going to explain this thing too much here, but we have used this binary system now to know that we have converted this 1011, which is a binary system, which is in binary system. We have converted it to decimal and we got 11. Don't worry, we'll talk more about decimal, binary and decimal. So, but the point here is this: computers use binary system. In the next section, in later section, we'll talk deep into binary system and decimal systems. Okay, so now, when we said that a bit is the smallest unit of data, all right? In computing, a bit is the smallest unit of data. Then now, a bit, you can combine bits together to form something bigger. 1 bit is just a single binary digit. It's either 0 or 1, all right? But when you have 4 bits, you will get something we call a nimble, all right? 1 bit is a single binary digit. When you put 4 bits together, you get what we call a nimble. When you put 8 bits together, you get what we call a byte. And check it very well. When you look at some things you store in your phone, you say, the size of this application is something megabyte. All right? Some documents will be kilobytes. Do you understand? Okay. And some will be bytes. So it's just putting up bits together. So if you put 4 bits together, you get 1 nimble. If you put 8 bits together, you get 1 byte. If you put 1024 bytes together, you get 1 kilobyte. That's why you say, this image is 1 kilobyte, is 10 kilobyte. Some are even in bytes. It is represented with B. Okay. So if you put 1024 kilobytes, you get megabytes. That's why you say this thing is MB. All right. The size of our files are measured in MB, basically. You see most of them will be in MB, some of them will be in KB. All right. Some of them will even be in B. All right. So that is the measure of the size of the data. And this data is actually measured by how many bits does it contain. All right. If it's just contain just 1 bit, all right, it is 1 bit. If it contains 4 bits, it is one nimble. If it contains 8 bits, it is 1 byte. If it contains 1024 bytes, it is 1 kilobyte, just like that. And we'd also have gigabyte. Some of you, when you check your hard drive, you see that your hard drive is 500 gigabytes. All right. It's just the size. It's just that, yeah, that your hard drive, what it says is that you can store data of up to 500 gigabytes. And remember, everything goes down to a bit. All right. We start with 1 bit, and then when we put bits together, we get megabytes, kilobytes, gigabytes, and terabytes. Okay. I hope you understand this. So what are data types? Now, the thing is this, in your computer, there are different types of data we work with. You can work with strings, you can work with characters, you can work with numbers, you can work with floating numbers, you can work with images, you can work with videos. So all these are different data types. So a computer must have a way of representing data. Do you understand? A computer must have a way of representing data. And then we talked about ISA in the last session. Now, it is in the ISA that the computer describes the different types of data types, the data they actually have. And a data type is not actually a data type unless the ISA of that computer has some operations they can perform on it. So when there is data, and that particular data type does not have any operations the computer can perform on it, it's not a data type. So every data type has set of operations that the ISA of that computer can actually perform on them. All right. So we have data types like a data type tells the computer what kind of data is being stored. All right. Now, all of them are still in zeros and ones. So all of them are still in sequence of zeros and ones. But the thing is that the data type determines how the computer interprets that data. When you store an image, they are all are still stored in zeros and ones. But if I have zeros and ones, and I have like two sets of zeros and ones, one can be an image, another one can be numbers. But that is why when we are writing code, you're going to see some examples of data types. We will tell the computer the type of data that we are trying to store. Then the computer knows how to store that kind of data. All right. So it also tells the computer how many bits to allocate. If you tell your computer that that the data type you're trying to store is a number, the computer cannot use more than 64 bits to store that data. The highest it can use, anything that looks like number, whether float or integer, it cannot use more than 64 bits to store it. Every computer have this. All right. So the data type tells the computer what kind of data are you storing and how many bits do I need to store this data. All right. Then, and it also tells the computer how to interpret the bits. I just told you now. You can have two set of sequences of bits. You can have two sets of it. All right. And when you have that, they can have different meanings based on the data type. So that data type will tell the computer how to interpret it. It will tell the computer to interpret it either as an image or as a video or as a sound. Okay? So that is why data types are very important. So why are data types important? It ensures memory efficiency. I remember when I started coding in C#, and if you want to write now, you say int, you will say you can even do byte, short, int 32, int 64. And I was like, what's really the meaning of all these things? I didn't understand it then until I started learning things like this. That is why we are giving you this course as the first foundational course to take. Okay, so when you tell your computer that this data type is going to be an integer, your computer would allocate enough memory for that particular data type. All right. It also prevents type-related errors. All right, because if you store something as a number and you want to perform an operation that data type does not support, there will be an error. So with this, it prevents the type-related errors. All right. Now, images have different operations that the computer ISA has actually described for them, and integers, floats, integers, characters, all of them have different types of operation that they can perform on them. Okay, so you cannot perform an operation that is for image on a number. It wouldn't go well. So when we specify the data types of our data, it ensures memory efficiency, it prevents type-related errors, and it enables type-specific operations. That's what I just mentioned now. You cannot perform an operation that is not specific to an integer. It will not work. Do you understand this? So, as we go on, when we get to programming, all right, you're going to understand these things better. All right. So, what are the common data types and how many bits do they use? Now, let's take a look at it. The integer data types, they are used for storing whole numbers. All right, they are used for storing whole numbers. Any integer, any number that is a whole number, we use the integer data types to store them. So this integer data type, they are categorized into two parts, signed and unsigned. Don't worry, in the next section, we'll be talking about integers. All right, and we'll also be talking about signed and unsigned integer data type. Okay, but now we have different types of this integer data type. It depends on the programming language actually, or even the ISA. So int8 means that we are going to be using 8 bits to store the data. So if you now declare a variable to be more than, if you say that a variable is int8, and you now give it a value that 8 bits cannot actually take, there will be a problem. I don't know if I just confused you, but don't worry, we'll get to that later on. Okay, so when you declare a particular value to be of data type of int8, it means that the computer would allocate 8 bits for storage of that value. That means if you try to store something that is more than 8 bits, that 8 bits can carry, there will be an error. We also have we also have the signed version and the unsigned version. I'm not going to talk too much about this now. Okay, I'm not going to talk too much about it. We have a particular section dedicated to integers, so we'll talk about signed and unsigned. All right. So the signed range is between -128 to 127, while the unsigned range is between 0 to 255. We also have int16. Int16 is a data type, it's an integer data type that the computer would allocate 16 bits to store it. So that means the size of int16 is 16 bits. Remember, the smallest unit of data is bits. But if you want to have more than 0, if you want to represent value that is more than 0 or 1, you have to use multiple bits. So if you want to store a value that is bigger, very, very big, that is bigger than 0 or 1, then that's where you will not use any of these integer data types. All right? So these are the signed range and also the unsigned range. All right. So we also have int32. It uses 32 bits. That's the size. It uses 32 bits to store data. And then we also have int64. It uses 64 bits to store data. All right. So these are for huge, very, very huge numbers, billions, trillions. Okay. Now we also have the floating point type. Don't worry, we'll also talk more about floating point. Okay. So it is used for decimal numbers. You know, decimal numbers that have decimal points after. All right. So we have two types. We have float 32 and we have float 64. Okay, so float 32 uses 32 bits to store this float, and it has approximate precision of 7 digits after the decimal point. Don't worry, we'll talk more about this. Float 64 uses 64 bits, all right, to represent data, to represent the floating point data. All right. Okay. So we also have the character types used to store text characters. If you want to store somebody's name, if you want to store the English alphabet, this is what we use. Okay. There's something we call ASCII. All right. We'll come to that when we talk about Unicode. When we talk about Unicode and character set encoding, we are going to explain what we mean by ASCII and Unicode. If I talk about it here, you cannot understand it, but understand that the character types are what we use to store characters, text characters, somebody's name, the name of a location, the name of a country, anything that has to do with characters. All right, we use the character types to store them. We also have Boolean types. This type is used to store anything like true or false, on or off, yes or no. All right, so it takes 1 bit. 1 bit is enough because it is either a yes or a no, or true or false. So 1 bit is enough because 0 is equal to false and 1 is equal to true. So if you have true or false value to store, you can just, if the value is false, the system will store it as 0 in the bit. If it is true, the system will store it as 1 in the bit, okay? So in memory, usually stored as a byte for alignment, okay? But now 1 bit is enough to store Boolean type, but in memory, they use 8 bits because of for some reasons, okay? Now, we'll talk about these reasons when we talk about memory and then word length. All right, we'll talk about that later. So let's take a look at some examples of data types in some programming languages. So in this is C++. So we have this data type. Now we are storing a value in a variable. Don't worry, we are going to be teaching you programming in C and C++. So the data type here is int. All right. So we are storing 100. And when you talk about of int, right now in C++ or C, int is 32 bits. This is something like int 32. All right, so C or C++ uses 32 bits to store their int data type. All right, Boolean is open is equal to true. Character grade is equal to A. Don't worry, we will talk about all these things when we start programming. But you can see every programming language have their way of representing these data types. But at the end of the day, these data types are declared or made available by the ISA of the computer. So these programming languages are just using abstraction. Remember we talked about abstraction. They are just using abstraction to hide some details that we don't even need, okay? So in Java, it's almost the same thing. All right, they have int, but in C sharp, all right, you have to either say it is a byte, it is a short, it is an int or int 32 or int 64. You understand? In C sharp, okay. Then in Python, Python does not even do type. There's something about Python we call it is dynamically typed. So Python uses inference. Okay, so you can see Python does not even specify the type of the variable, but don't worry, as we go, you're going to understand the reason why this is like this, okay? All right, so Python abstracts away strict bit-based data typing. Python doesn't want you to worry yourself about the data types. Once you give it the value, Python will use something we call inference. All right, it will infer the type of data based on the value you give it. So with that, you're writing less code and it's abstracting so many things you don't need to worry yourself about. But understanding it helps optimize performance in low-level scenarios. All right. So in as much as Python abstract this data typing for us, you need to also understand it so that when you want to optimize the application, you can actually do it better. Okay. All right. So real-world applications of bit and data types. Number one is data compression. All right. So when you're compressing your data, you're using bit level optimization. Basically, you're compressing data. Look at it. Let's say a particular data size is 20 MB. When you compress it, you're trying to reduce the number of bits that is used to store it. So you can compress it from 20 MB to 200 kilobytes, or from 20 MB to 200 kilobytes. Do you understand? So you have compressed it. Basically, you have reduced the number of bits that is used to represent or store that data. That is basically what data compression is. In network protocols, all right, network protocols define fields in exact bit lengths. All right, we'll still talk about network. We'll talk about network and this network protocols. You're going to understand. All right, when you're even streaming data, these data are passing by bit. Do you understand all these things? Okay, embedded systems use exact data types for memory efficiency. So you need to understand these bits, these data types. You need to understand all these things, how they work. And that's why we have taken you through this journey like this, making you understand these fundamental things you need to know, okay? So even if you're going into cybersecurity, artificial intelligence, stuff like that, machine learning, you need to understand all these things because they have a role to play. Cryptography uses heavy bit manipulation. All right. So, of course, if you want to do cybersecurity, you want to do Web3 and blockchain, you have to understand cryptography very well. And for you to also understand cryptography, you need to understand how this bit works. Okay. Game development often involves custom data structures to save memory. So if you don't understand these data types and the number of bits used to store them, you might not select the right data structure for memory optimization. Okay, so thank you very much. I hope you grab what was taught here. And in case you have any difficulty in understanding something, please reach out. All right. Our WhatsApp is always available. Do your assignment and write your test. And I'll see you in the next section.